This movie is about the formation of stars and the solar system. Again, please take notes, copying down what's in yellow and writing questions in the margin. Nebulas. Nebulas are interstellar clouds of gas and dust and are where stars and solar systems form. Some scientists believe that supernovas and the shock wave from a supernova can cause the nebula, the cloud of gas and dust, to start collapsing to form stars and or planets. This is a picture with an example of a supernova inside. It's a star that's exploded and letting off a tremendous amount of light. Over time, that star would eventually dim, and you wouldn't see it anymore. The interstellar gas cloud, once it starts collapsing, is going to pull together because of gravity. Remember, anything that has mass is going to attract anything else that has mass. And so it'll pull together in a disk. As it pulls together, it'll continue to spin, and the young star will form at the center. The planets, if there are going to be planets, will form in the disk on the outside. Here's some pictures of stars with the nebula surrounding them. You can see that the nebula has been pulled, the gas has been pulled away from this young star, and that's where they believe the planetary disk may be forming. So scientists believe our solar system formed that way, that the cloud of gas and dust started collapsing, most of the mass was pulled into the center, the sun, again 99% of all the mass in the solar system, and then there was a small amount outside in the disk that was pulled together by the planets, and as the time passed, the planets pulled more and more of the gas and dust and ice and gases around the sun into them, as the sun pulled in stuff as well. So the solar system was formed and is still being held together by gravity. That's why gravity is such an important force. The Kuiper Belt has, as we've learned, many small objects believed to have been left over from the solar system. It's like the asteroid belt, except that these are not made of rock and metal, and instead made of frozen water, methane, and other gases. Scientists believe that the gravity from Jupiter has helped hold the Kuiper Belt in place, and that the Kuiper Belt has actually probably pulled Jupiter a little farther away from where it would otherwise be in our solar system. One of the most important things to realize is that our understanding of how stars form actually helps explain the way our solar system is. As you guys have learned, the terrestrial planets are in close to the Sun, with Mercury, Venus, Earth, and Mars. Those are all rocky planets made of rock and metal. And then the gas giants are far away from the Sun: Jupiter, Saturn, Uranus, and Neptune. Scientists believe that when the Sun was first formed, it had a very large solar wind, and it blew that solar wind, blew all the really light particles, not very dense particles like hydrogen and helium, out away from the inner part of the solar system into the outer solar system, where they then were pulled together by the gravity of the planets. And that's why that the outer planets are gas giants and the inner planets are terrestrial planets made of rock and metal. Now we need to understand why some planets and some objects are round, but then some other objects like asteroids are not round and have strange shapes. And again, it comes back to gravity. Objects that have a lot of mass must be round, and the reason is gravity. The round shape is going to guarantee that all the forces are balanced. So the total gravitational force pulling down is going to be equal to the force of the rock pushing up. And that'll only happen if the object is round. So if it's a large enough object, gravity will make the object round. We can see why if we look and analyze the forces that might be acting on something. Here, the force of gravity pulling in toward the center on the side that's not very large is a pretty small force. If we look at the other side, we have a lot more mass. We're going to get much larger force. As you probably already recognized, these forces are unbalanced. So with any time we have an unbalanced force, we're going to have something accelerate. In this case, the rock and stuff itself would accelerate and flow, and so it would move out until the forces were balanced when the object is basically spherical. You can see examples of that. Here's a number of asteroids, including two of the moons from Mars, Deimos and Phobos, believed to be captured asteroids, and Gaspar, which is a current asteroid. All three of these objects do not have enough mass to be completely round, and you can see they have strange shapes instead. That concludes the material that you're required to know and that you'll be tested on. Here's a few things that many students are interested in. You won't have to take notes on it, you will not have a test on it, but if you have questions about it, we'd be happy to go over it in class. Scientists believe they understand the life cycle of stars, including stars like our Sun. They believed it was formed about 4.5 million years ago, again from a nebula as we talked about, and they believe it'll probably continue to burn as it is now for another 4.5 billion years or so. At that point, at about 5 billion years from now, it will have burned up so much of the hydrogen and changed that into helium through nuclear fusion that once it starts burning a larger percentage of helium, the outside of our star will expand and our sun will become a red giant. When it does that, the surface of the star will probably be out at least past Mars and getting close to the asteroid belt. And it'll be a red giant like Betelgeuse that we learned about in the previous lesson. Our sun does not have enough mass for all that material to be pulled back into the center and for it to explode as a supernova, as many stars with about 3 to 5 times or more the mass of our sun will do. Instead, what will happen is after it's been a red giant, eventually it'll slough off the outer material and you'll just get left with a very, very hot center, and it'll be considered a white dwarf. And over time, eventually that will cool. The phases of the moon. You can understand why the moon changes over about a monthly cycle if you understand how it and what's going on. The moon is rotating around our Earth, and it takes about 28 days for it to make one complete revolution. And so if it starts here and slowly is rotating around, basically when the moon is about here, you'll see a waxing crescent. When it's halfway, the part that you can see is only the part that's lit up. The part that's in shadow you can't see, and that would be a half moon, again about 7 days or so after the new moon. When the moon is all the way back behind the Earth, you would see all of the surface, so then you would see just the full moon. And then again, as it continues to move around, you would see another half, but the other half will be lit up, and finally you get back to a new moon again. This is a little easier to see and understand if you use objects to help you out. One good way to do that is use a flashlight and maybe an apple or a tennis ball and revolve that around your head, and your head would be the Earth and that apple or tennis ball would be the moon. If you have some questions about this, feel free to ask in class. Eclipses, both lunar and solar eclipses, are also interesting to understand. One of the reasons a lunar eclipse is so rare is that even though the moon does revolve around the Earth, it very rarely passes in the exact same plane as the Earth and the Sun. It's usually just a little bit below or a little bit above. Occasionally it'll pass directly through the shadow of the Earth, and that's a lunar eclipse. More rare than that is a solar eclipse. When a solar eclipse, the moon will be in front of the sun, and so the sun's light will be casting the moon's shadow onto the Earth, and that is a solar eclipse. Since the moon is much smaller than the Earth, that is more rare than a lunar eclipse. Because of gravity, the far side of the moon we actually cannot see here from Earth. We had to send spacecraft up to get our first look at the far side of the moon. We see the same side of the moon all the time. So the moon rotates around as it's revolving around us, and we always see the same side of the moon. One of the last really interesting things to learn is about gravity and the tides. The high and low tide that happens twice a day is caused because of gravity. It's caused from the moon's gravity and the sun's gravity. As you guys learned, objects that are the force of gravity is affected by the mass of the object, but also how close it is, and distance is really important. So the moon actually plays a larger role than the sun in terms of the tides. Since the water can move on our surface, when the moon and the sun line up together, that's when you get really, really high and really, really low tides of the month. That'll happen twice a month. If the moon is in like the first quarter or the third quarter, and so it's not lined up directly, the moon and the sun will kind of have competing effects on the water on the oceans of the earth, and so you still get high and low tides, but they won't be nearly as extreme as when everything lines up with either a full moon or a new moon. Here's one more picture to kind of help you understand that. Spring tides are when you're going to have the most extreme tides because both the moon and the sun are pulling it in the same direction. And when you have them pulling at perpendicular angles to each other, like with neap tides, that's when you're going to have not very extreme tides. You'll still have a high and low, but it'll be much less extreme and much less of an exchange of water. That's it for this lesson. Hope you enjoyed it. Again, if you have any questions, please feel free to ask in class and we'll make sure you understand it. Thanks again.